So regardless of how you do it, whether you write out 2 to the power of 7 times 0 and 2 to the power of 6 times 0 and so on and so forth, like we've shown in other examples, it doesn't matter. The key here is to get yourself to that value. What does it equal specifically? So let's focus on the very last one they have for us here in our example of 6. If I want to figure out what 6 is in binary, what are we going to do? Well, we have our 128, our 64, our 32, our 16, the 8, the 4, the 2, the 1. And this chart is so important, as you can see, because it's going to help you out. Know the powers of 2. Know the powers of 2. So 128 and 6, well, that's too big, that's too big, that's too big, that's too big, that's too big. Ooh, 4. Perfect. I found a 4. That's going to work. So now we have 4 plus 2 is what? Well, 4 plus 2 is giving me 6. So that's a 1. And there we go. Don't need that anymore. So I already have my value. So 4 plus 2 is 6. It's 6. So now I've got 0, 0, 0, 0, 0, 1, 1, 0. There we go. Exactly as they did it for us on screen. So 4 plus 2. And this is going to work with any number you want to work with. So let's just pick a number out off the top of our head. Throw a number at me. Throw a number at me. Anything you want. What do you want to do? What do you want to do? What do you want to do? Oh, 176? All right. So 176. So I'm going to write down 176 here. Let's go ahead and grab our crayon. 176. So 176 is the decimal number we want to practice with right now. So we have 128, 64, 32, 16, 8, 4, 2, 1. All right. So 128. Do we need a 128 to get to 176? Of course we do, because 128 is less than 176. So I'm going to need a 128. Do I need a 64? Well, in this case, just take 128 and add 64 to it. What does that equal? 192. So 128 and 64 is too much. So I do not need the 64. I'm going to put a 0 there. What about 32? Well, 128 plus, 128 plus 32 is what? 160. Well, that's going to work for me because 160 is still less than 176, right? So I'm going to go ahead and put a 1 there. So now I'm at 160. So I'm going to keep my running total down here, 160. Now, if I add a 16 to 116, what do I get? I get 176, don't I? I do get 176. So 160 plus 16 is now 176 with my running total. So I don't need an 8, don't need a 4, don't need a 2, don't need a 1. So there you go. There's 176 in binary. So what I recommend you do is I recommend that you take some time, grab any decimal number from 0 to 255 and practice converting it to binary. Now, why did I stop at 255? Why? I'm going to show you that now. Why stop at 255? Let's clean this up. Well, what if I had a value of 255? 128, 64, 32, 16, 8, 4, 2, 1. All right, so do we need a 128 to make 255? Yes, we do. That's going to give us a grand total of 128 as my running total right now. All right, what about 64? Do we need 64? Well, if we take 128 and add 64 to it, we get 192. So now my running total is 192. 128 plus 64. What about a 32 here? What about a 32? What do we get? Yeah, it's still less than 255 if I add 192 plus 32. So what's my running total now? So add 32 to that, we get 4. 224. All right, so my running total is 224 now. Let's go ahead and add 16 to that. What do we get? 240. Right, so my running total is still going. We're at 240 now. Let's go ahead and add 8 to that. We get 248. Let's go ahead and add 8 to that, or 4 to that now. What do we get? 252. Let's add 2 to that. We get 252, or 254. Let's add a 1 to that. What do we get? 255. Wow. All right. So that's why I said 0 to 255. 0 to 255. That's why I said that. Because all ones is 255. All zeros is 0. So the maximum value we could have in an octet in an IPv4 address is 255, all ones. The minimum we could have in an octet is all zeros, which equals 0.